Now class, let's talk about Green's functions. I think isa ito sa mga pinakamahalagang topic na dapat yung malaman. And if mag-grad school kayo ng physics, dapat alam nyo to. Dapat alam nyo kung paano gumamit ng Green's functions. So now, class, to start, suppose we have, let's say, a point charge. Point charge Q at position X prime. So yung Q natin, naka-situate sa X prime. So kunwari ito yung Q. Yung kanyang position ay X prime. Tapos let's say class, yung field point, yung gusto mong kunan ng electric field ay X, 'di ba? Usually X prime is the source, X is the field point. Tapos itong vector na to, yan yung X minus X prime, 'di ba? So now class, with the point charge set up, ang V of X natin, potential, yan ay 1/4 pi epsilon naught Q over X minus X prime. Diba? KQ over R. Yan lang yung potential natin pag point charge. Now class, in this setup also, yung density natin, yung charge density natin, rho of X, that is Q Dirac delta of X minus X prime. Class, yung lecture natin kahapon, di ba, we talked about charge densities. So class, ang point charge, yan ay Dirac delta. Kasi di ba, zero siya everywhere else, pero infinite. Ang density ng point ay infinite at that particular position. So kaya siya Dirac delta. Now let us recall. Class, di ba, yung kakatapos lang na lecture natin is on Laplace equation. Ngayon, mag-Poisson equation na tayo. Poisson equation is the general form ng Laplace equation, di ba? Del squared V equals negative rho over epsilon naught. Di ba kapag Laplace, zero to. Pero kapag Poisson, general na yan. So with the previous example, ang del squared ng V ng 1/4 pi epsilon naught Q over X minus X prime, yan ay equals sa negative, anong rho natin? Q Dirac delta of X minus X prime over epsilon naught. So class, itong mga constants, pwede kong, ayan, cancel na yan, di ba? Yung Q tsaka epsilon naught. So we have del squared ng 1 over X minus X prime, ang kanyang Laplacian, yung 4 pi lagay ko sa kabila, negative 4 pi Dirac delta of X minus X prime. Class, mahalaga to. Pero hindi pa to yung main result natin na box lang natin para maalala nyo mamaya. So class, ang Laplacian ng 1 over R, 1 over X minus X prime, ay Dirac delta. Now class, let us recall yung Laplace equation. Diba kapag Laplace equation, rho equals 0. Kapag Poisson naman, kapag Poisson equation, rho is arbitrary. So class, yung Green's function, we will use that to solve for the Poisson equation. Kaya mahalagang malaman nyo yung Green's function method. So class, balik tayo from the past lectures. From the classic image problem. Yung method of images. So from the classic image problem, di ba meron tayong ano to? Meron kang Q at Z equals D. Tapos ito grounded. Tapos meron kang image charge. Negative Q at Z equals negative D. Diba ito yung last time, naglagay lang tayo dito ng image charge. Tapos yung potential natin, isulat ko lang, yan ay V of X equals V of XYZ. Yan ay equals sa Q over 4 pi epsilon naught. Sana to? Diba? Yung contribution lang sa dalawang charges. X squared plus y squared plus z minus d squared minus 1. Plus, nire-recall lang natin to ha. X squared plus y squared plus z plus d squared. Yan yung potential natin in the classic image problem. Tapos yung another example, 'di ba yung ano ba to? Yung spherical naman. Ano ko, spherical boundary dito. Tapos meron kang Q at a distance A from the radius. Tapos meron kang radius R. Tapos yung ating boundary ay grounded din. Tapos meron tayong potential na V of R theta phi. That is equal to Q over 4 pi epsilon naught. Mamaya class, babalikan natin tong mga to. Sinusulat ko lang ngayon. R squared plus A squared minus 2RA cos theta minus 1 over square root ng A squared R squared over R squared plus R squared minus 2RA cos theta. Yan yung ating potential with this setup. So now class, yan lang yung result natin from last time. Now, for a point charge, let's say Q at X naught. Meron kang point charge Q at X naught equals X naught, Y naught, Z naught. So class, ang kanyang density, rho of X, yan ay Q, Dirac delta of X minus X naught, Dirac delta of Y minus Y naught, Dirac delta of Z minus Z naught. Class, ito lang yung delta of X ha. Ito lang yan. Or delta of X naught, I should say. Now class, this is for Cartesian. Now, if we convert that into spherical coordinates, rho of X is Q over R squared sine theta, Dirac delta of R minus R naught, Dirac delta of theta minus theta naught, Dirac delta of phi minus phi naught. This is for spherical. So class, ito Cartesian, ito yung charge density sa spherical. Meron ka lang na dito, R squared sine theta na factor since conversion lang yan. Conversion factor lang yan. Kasi class, naalala nyo yung d cube x ng spherical, meron kang R squared sine theta, dr d theta, d phi. Ito yon, yan lang yon. Kailangan lang nating i-divide ng R squared sine theta para ma-convert into spherical. Now, with all that, let us proceed to Green's theorem. So, Green's theorem. Siguro na-encounter nyo na to sa 112, 111, 112. So, let us now recall, umpisa tayo sa divergence theorem. So, ang divergence theorem, sinasabi niyan na divergence ng A, volume integral, that is equal to the surface integral ng A dot n hat dA. So, yan yung ating divergence theorem. Now, ang gagawin natin, we let A, the vector A, be a product of two functions, one scalar, one vector. Phi del psi. Ito ay vector, di ba? Multiplied by a scalar, siya ay vector din. So these are arbitrary. Where phi and psi are arbitrary scalar fields. So these are arbitrary scalar fields. Now, what we'll do, we get the divergence of A. So ang del dot A natin, yan ay equal sa del dotted with phi del psi. Ito lang yung A natin, di ba? Nasok ko lang doon. So that is equal to product rule, phi, left derivative ng right, plus right, derivative ng left. Del dot, sorry. plus del phi dot del psi. Yan ang ating product rule for this equation. Now, kung hindi nyo maalala yan, balikan nyo yung lecture 1. So, ito yung product rule for that specific na equation. Now, class, we have del dot A. Ano naman ang A dot n hat? Ang A dot n hat, yan ay equal sa phi del psi dotted with n hat. Class, ang del psi dotted with n hat, yun yung derivative at the normal. So this is phi partial psi partial n. This is your normal derivative. Di ba class? Ang gradient, yan ay derivative along x, along y, along z. Tapos kung i-dot mo sa n hat, yun lang yung derivative at the normal. Di ba ito yung normal? Normal coordinate yan. Kung dinat mo yun sa gradient, yun ay yung normal derivative. So one component lang, derivative at the normal coordinate. So yun yung ating a dot n hat. So bali yung del dot a, ilagay natin to. Yung a dot n hat, ilagay natin to. So let us rewrite the divergence theorem. We have. So yung volume integral ng ano to, phi del squared psi plus del phi dot del psi d cube x. Yan ay equal sa surface integral ng phi partial psi partial n dA. Now class, actually, we just derived Green's first identity. Nire-relate lang niya yung dalawang scalar fields phi and psi with this equation. So let's call that equation 1. Now class, since phi and psi are arbitrary, we can shift. So shift, yung phi gawin nating psi, tapos yung psi gawin nating phi. Since wala naman tayong sinat na specific values for them, di ba? So bali ang mangyayari, volume integral, ito magiging psi, ito magiging phi. Ayan, pagpapalitin lang natin sila. What we'll do, so what we'll get is psi del squared phi plus del psi dot del phi phi dot yan d cube x. That is equal to surface integral ng psi partial phi partial n dA. Now that is equation 2. Kasi wag kayong malito pinagpalit ko lang yung phi and psi. Kaya nangyari yan. Now class, ang gagawin natin, the next step is to get 1 minus 2. Yung equation 1, ima-minus natin yung equation 2 doon. So bale, class, ang makikita natin, ito, minus this 1, yan ay magiging 0, di ba? Since ang dot products, commutative yan. Yung del psi dot del psi, equal yan sa del psi dot del phi. So, magka-cancel lang yung dalawang terms na yan. Now, what we'll get is the following. So, meron tayong, ano ba to? Volume integral ng phi del squared psi minus psi del squared phi. Tapos minus 0, di ba? This one minus this one minus this one equals sa this one minus this one. So, bali equal yung right-hand side, d cube x, surface integral ng phi partial psi partial n minus psi partial phi partial n dA. Now class, we just derived Green's second identity. Ito na yon. Or actually, ito na siya. This is your Green's theorem. So, Green's theorem. Pero hindi pa yan yung endpoint natin class Umpisa pa lang yan. Then we note, reminder lang, na phi and psi are arbitrary scalars. Scalars. So kung arbitrary yan, pwede tayong pasok ng kahit anong value, di ba? So now, we let psi equals, let's say, 1 over x minus x prime. Yung 1 over r. Scalar to, di ba? And we let phi be the potential, p of x. So this is the potential. Arbitrary yan, pwede tayong magpasok ng kahit anong value. Now class, recall natin, Poisson equation. Sa Poisson equation, meron tayong del squared v that is equal to negative rho over epsilon naught. So class, ang gagawin natin, yung Green's second identity or Green's theorem, ipasok na natin yung 1 over x minus x prime, tsaka v of x. So ang mangyayari dyan, we have volume integral ng v of x del squared ng 1 over x minus x prime minus 1 over x minus x prime del squared v d cube x. Yan ay equal sa surface integral ng v partial n ng 1 over x minus x prime minus 1 over x minus x prime partial v partial n dA. So now class, may crucial tong next step natin, we shift to prime coordinates. Class, itong volume mo, itong volume na tinutukoy natin ay sa field point, di ba? So, field point. Ang gagawin natin, pupunta tayo sa prime coordinates, mag-shift tayo into the source point. So, volume ng source, yan. Kahit wag nyo isulat yung source, nilalagay ko lang as a reminder. Volume ng source, so bale ito, magiging v of x prime. Yan, di ba? V of x, shift to prime, magiging v of x prime. Plus, ano ang del squared neto? Ano ang del squared ng 1 over x minus x prime? From earlier, yan ay negative 4 pi Dirac delta. Ito. So, bali, meron tayong negative 4 pi Dirac delta. Class, siguro yung iba sa inyo natatakot sa Dirac delta, no? Pero hindi, huwag kayong matakot dyan. Matuwa kayo pag may Dirac delta. Kasi, di ba kapag may Dirac delta sa loob ng integral, sobrang dali nang isolve ng integral. Yung value lang ng function na yon at that particular point, yun na yung sagot. So kapag nakakita kayo ng Dirac delta, huwag kayong matakot. Matuwa kayo pag may ganyan. So i-shift niyo yung mindset nyo. Parang nag-shift lang to prime coordinates. So nasa na tayo? Lagay 4 pi Dirac delta. Okay. Minus 1 over x minus x prime. Class, ano ang del squared v? Class, ano to? Ano yung del squared v? Sige nga. Ano yan? Walang sumasagot. Yan ay, eto, negative rho over epsilon naught, di ba? Ayan lang yun. So, negative rho over epsilon naught. Class, baka mag-overtime tayo, ha? Kung may class kayo ng beyond 9:30, you can leave the meeting. Pero, yeah, baka lang mag-overtime tayo. So, yan na yun. Negative rho over epsilon naught 1 over x minus x prime d cube x. That is equal to surface integral ng v partial n prime. Take note, ano na tayo, prime coordinates. 1 over x minus x prime minus 1 over x minus x prime partial v partial n prime dA prime. Plus d cube x prime pala to ah. So d cube x prime yan. Itong kabila, dA prime. Class, simplify lang natin. Medyo magulo yung equation eh. Now, we have volume integral plus source to ah. Tatandaan nyo source. Negative 4 pi v of x prime Dirac delta of x minus x prime d cube x prime plus volume integral source ulit. Now, 1 over epsilon naught x minus x prime rho of x prime d cube x prime. Yan ay equal sa surface integral ng v partial n prime ng 1 over x minus x prime minus 1 over x minus x prime partial v partial n prime dA prime. Now class, sige kayo naman. Anong value nito? Meron kang Dirac delta. So anong value niyan? Sige, anyone? Meron kang v of x prime. Tapos meron kang Dirac delta. Ito yung function mo. Tapos meron kang kasamang Dirac delta. Tapos in-integrate mo yon. Anong value niyan? Magtabag nga ako. San si Axel dyan? Anong value ng f of x, Dirac delta of x minus x naught? Dx. Anong integral niyan?
Sir, sabi niyo po kanina, value at that point po.
So, f of x naught. Diba? So, ano to? So, class ito ay negative 4 pi v of x. Diba? Plus, ini-integrate natin at the prime coordinate. Bali, yung matitira is yung unprimed coordinate value at that point, v of x. So, here, so ito negative 4 pi v of x. Bali, meron na tayong equation for v of x. Ililipat lang natin ito sa kabila. Tapos, magdi-divide tayo ng negative 4 pi on all terms. So, here we have v of x that is equal to 1 over 4 pi epsilon naught volume integral ng rho of x prime d cube x prime over x minus x prime plus 1 over 4 pi surface integral ng ano to? 1 over x minus x prime partial v partial n prime minus v partial n prime ng 1 over x minus x prime dA prime. Class, di ba negative dapat to? Kasi nag-negative 4 pi. Pero, ano na, pinagpalit ko lang yung order netong dalawa. Kaya nauna itong 1 over x minus x prime partial v partial n kesa dito. Para lang mawala yung negative. Okay, class? So, yan yung ating equation for the potential. Pero hindi pa ito yan. Hindi pa ito yung endpoint natin. We will use that. Then we will use the Green's functions na. Class, before we proceed, may tanong ba? Naintindihan nyo ba yung discussion natin? Si Miss Erin Beatrice, may question ka ba?
Wala naman po, sir.
Okay. Si Easy Franco.
Wala po, sir.
Si Miss Angela May.
Wala pa naman po, sir.
Okay, so wala pa naman. Sure kayo Sure kayo naintindihan nyo dahil kailanganin natin to for the next topic, which is the Green's functions itself. Green's function. Di ba puro tayo Green's theorem, Green's first theorem, Green's second theorem. Let's now proceed to Green's functions. Now, in electrodynamics or electrostatics, the Green's functions. Functions marami. Marami ang Green's functions. G of x prime satisfy. So ito sa electrostatics. So G of x prime satisfy the following. Del squared G of x prime that is equal to negative 4 pi Dirac delta of x minus x prime. Yan yung equation na sinasatisfy ng Green's functions. Now class, kanina, sige, class, naka-encounter na ba tayo ng Green's functions before? Sige, tatanong ako. Since si Noel Denise, naka-encounter ka na ba ng Green's functions before? Wala, hindi nagre-respond. Si Godwin, naka-encounter ka na ba ng Green's functions before?
Wala pa po ata, sir.
Wala pa? Okay, sabi ni Noel, wala din. Meron na, may na-encounter na kayo before. Teka, balikan natin na. Tignan nyo, del squared G, negative 4 pi Dirac delta. Saan na yun? Ito, del squared G, yun yung G, negative 4 pi Dirac delta. So, isa tong Green's function. Ayan. Okay, so naka-encounter na kayo kanina lang. Naka-encounter tayo ng isang Green's function. Sige. Isulat natin yan. So, using the point charge example. So, di ba del squared ng ano to? 1 over x minus x prime. Yan ay equal sa negative 4 pi Dirac delta ng x minus x prime. Diba kamukhang kamukha? Ayan. Yan yung G natin. Therefore, we note that 1 over x minus x prime is a Green's function. Again, marami ang Green's functions Isa lang yung 1 over x minus x prime sa Green's functions. Now, in general, ang Green's functions, we can write that as 1 over x minus x prime plus other functions, f of x prime. Class, di ba, kapag nag-solve, kunwari sa differential equations, di ba meron kang particular, tapos meron kang complementary solutions. So, ganun din dito. Ito yung particular natin, tapos ito yung complementary solutions. Now, kapag complementary, di ba, sinusolve, kapag complementary solution, yung right-hand side, ginagawa nating 0. So, where the complementary solution, f of x prime, satisfies del squared f x prime equals 0. Diba? Kapag complementary 0 to, yung right-hand side. Plus, anong equation to? Del squared f equals 0. Anong equation yan? Class, di ba ito yung Laplace equation? Di ba? Del squared v equals 0. Nilagay ko lang f. So class, again, from Green's theorem, nasa na yung Green's theorem kanina? Ito. Ang gagawin natin, yung V, yung phi, gagawin nating V. Pero this time, yung psi, gagawin nating Green's function. Hindi lang siya 1 over x minus x prime. I-generalize natin into 1 over x minus x prime plus other functions. So, rewrite natin. So, from Green's theorem, let phi equals V and psi equals the Green's function, xx prime. Bale, meron tayong V of x. Ito pala. So, di ba ito yung conclusion natin kanina for V of x? Yung 1 over x prime, x minus x prime, palitan natin ng Green's function. So, this is 1 over 4 pi epsilon naught volume integral ng rho of x prime g of x prime d cube x prime plus 1 over 4 pi surface integral ng g of x prime partial v partial n prime minus v of x prime partial g of x prime partial n prime dA prime. Now class, ito na yung potential natin. 'Di ba? Ang problem lang naman natin mag-solve ng potential. Ito na siya in the form of Green's functions. Yan na yung ating V of x. Okay, so with that equation, magso-solve tayo ng actual na physical problems. So, 'di ba, nakakalito ng mag-derive ng Green's functions or mag-derive nito, tapos i-apply pa natin sa physical na system. So, tatry natin simplihan yan, class. Meron tayong 3 terms. 1, 2, 3. So, yun yung tandaan natin. Now, from Green's, para ma-simplify yan, let us do some boundary conditions. Diba sa pag-solve ng ordinary differential equations, yung undetermined coefficients, so-solve nyo by boundary conditions. Ganon din dito. So we have 2 boundary conditions. One is the Dirichlet. So Dirichlet boundary conditions. Kasi ang sinasabi nito, potential is specified on the boundary surfaces. 'Di ba? Usually, ganun yung ginagawa natin. Dun sa method of images, potential is 0 at the boundary. Or dun sa sphere na example, dun 'di ba potential is 0 at the boundary. So potential is specified on the boundary surfaces. Kapag ganito class yung case natin, the Green's functions is 0 for x prime on the surface S. So yun lang yung ibig sabihin ng Dirichlet boundary condition, na at the surface, ang iyong Green's function ay 0. Okay, class? Bale, with that, tignan nyo yung example natin, ay yung potential natin dito. Area integral, surface integral yung tinitake natin. Bale, kung ano man yung value ng Green's function at that area or at the boundary, yun ay 0 under Dirichlet boundary conditions. Bale, class, automatic, itong first term natin, 0 na yan. Diba? G of x prime evaluated at the area, at the boundary, 0 to using the Dirichlet boundary conditions. Therefore, masisimplify yung ating V of x. Saan na yun? Bale, ang V of x natin, yan ay equal sa 1 over 4 pi epsilon naught volume. Again, class, itong volume natin where there are charges. Diba? Ito yung source volume natin. So, ito ay rho of x prime, g of x prime, d cube x prime, minus 1 over 4 pi. Class yung second term na lang yung matitira, di ba? Kasi 0 to. Ito kasi derivative yan. Derivative to, so hindi siya automatically 0. So minus, yan, 1 over 4 pi surface integral ng v of x prime partial g of xx prime partial n prime dA prime. Class, ito yung madalas na gagamitin natin. Potential. So, 2 terms na lang. So, under the Dirichlet boundary condition, yan yung gagamitin natin. Now, second, boundary condition, we have the Neumann. Neumann boundary conditions. Ang sinasabi class ng Neumann boundary conditions, partial g xx prime over partial n prime. In derivative, ito 'di ba value of the function. Ito naman value of the derivative of the function. Yan ay equals sa negative 4 pi over the surface area. Yan yung ating Neumann boundary condition on the surface. Class, kunwari infinite plane. O di ang surface area mo 0. O di madali, surface area mo infinite, I should say. Bali itong whole term 0. Or let's say yung sphere, 4 pi r squared. So bali ang value lang nito 1 over r squared on the surface. So yan lang yung sinasabi ng Neumann boundary condition. Pero class, we actually need only one. We will only use one boundary condition, which is the Dirichlet. Kasi medyo redundant. Tsaka mas madali yung Dirichlet kasi using 2 leads to excessive. Leads to excess. So 1 is enough. So ang gagamitin natin yung Dirichlet boundary condition. Class, ano bang use ng Green's function? So isulat natin, g of xx prime actually gives the potential at position x due to a unit point source. Due to a unit point source. Syempre, at x prime yun, di ba? Tandaan nyo, class, prime coordinates palaging source yan. Then, yung isa, yung fxx prime. So, yung fxx prime satisfies the Laplace equation. So, this satisfies the Laplace equation inside the volume. Inside the volume of interest. Tapos, yung physical representation niya, so it physically represents a charge distribution outside the volume. Outside the volume to match the desired value on the surface. Class, ang fxx prime, it represents a charge distribution outside the volume to match the desired value on the surface. Class, di ba ginawa na natin to sa method of images? Tignan nyo. Charge distribution outside the volume to match the desired value on the surface. Tignan nyo yung example natin sa method of images ha. Asan na yun? Ito. Sa classic image problem, ang volume of, di ba yung volume natin nasa source, itong upper volume. Yan yung volume natin. Kasi, naglagay tayong image charge outside the volume. Plus, parang ito yung use ng f of xx prime. Ito yung volume of interest natin. Outside that, ito, maglalagay tayo ng image charge dyan. Diba? Or to match the boundary na v equals 0. Tapos diba tatanggalin natin yung boundary. Or let's say itong isang example, ang source points natin ay nasa labas, di ba? So yung volume of interest natin is yung outside. Ito yung prime. Tapos yung inside, naglagay tayo ng image charge yan to match the boundary. The boundary condition na V equals 0 din. Di ba? So class, baka malito kayo Hindi porket outside ang sinabi, ito na yon. Ang volume of interest natin in this example, ang source charges ko ay nasa labas ng sphere. Di ba meron tayong dalawang regions? We have region 1, region 2. Nasaan ba ang aking sources? Nasa labas. Therefore, yung outside nun ay itong loob. Kaya taglagay tayo ng image charge dito sa loob. Okay, class? So, medyo parallel yung Green's function method sa method of images. Now, before we look at a particular example, may tanong ba? Nakakasunod pa ba kayo? Si Calista Pauline. May tanong ba? Wala.
naman po, sir.
Okay, si Sarah.
Medyo naglo-loading pa, sir, pero kaya naman.
Sige, kung nalilito kayo, ito lang. Balikan nyo yung lecture mamaya. Tapos, ito yung tandaan nyo. Saan yung tatandaan nyo? Ito. Yan lang ang potential. Sa electrostatics, ang concern lang natin ay potential. In this method, kukuha tayo ng potential gamit ang Green's functions to solve the Poisson equation. Di ba class yung Laplace? Mahirap na yan. Paano pa kaya to? Ito arbitrary, di ba? Pwede yung napaka-complicated na function yan. So, ito mahirap na. Ito sobrang hirap. Pinadali natin ito gamit ang Green's functions. Class, ito madali lang to. Kung medyo na-overwhelm kayo, madali lang yan. Tatandaan nyo lang, ano ba ang kailangan nating malaman dito? Rho. G. Kung alam mo ang G, alam mo ang partial G. Tapos yung boundary. Okay, so isa-isahin nga natin. Charge density. The Green's function itself. And the boundary condition. Yan lang. Tapos masosolve mo na yung potential. Class, ang pinakamahirap ay ito. Finding the Green's function. Pero gagawin na natin yan in this particular example. Sige. Kung nalilito kayo, okay lang. Actually, isa to sa mga pinakamahirap na topic dito sa electrostatics. Pero, yeah, kapag paulit-ulit yung ginawa, maintindihan nyo naman yan eventually. Sa example tayo. Find the Green's function. Find g of x prime for an infinite plane. Class, isipin nyo yung method of images. Infinite plane along xy at z equals 0 under Dirichlet boundary condition. So, meron kang infinite. Class, ang Green's function ay para sa geometries, para sa mga shape. Hindi ka maghahanap ng Green's function ng isang charge distribution. Maghahanap ka ng Green's function ng isang shape. So, ang shape natin dito ay isang infinite plane. So, ito, meron kang infinite plane, z equals 0, infinite yan, tapos x, y, z. Hanapin natin ang Green's function yan. Di ba ang Green's function, ito, meron na tayong first term, hindi natin alam ang second term. So, yun yung isosolve natin. So, ang g of x prime, yan ay 1 over x minus x prime plus f of x prime. So, ito, class sa Cartesian, ang 1 over x minus x prime, yan ay, di ba, 1 over square root of x minus x prime squared plus y minus y prime squared plus c minus c prime squared. Yan yung ating x minus x prime sa Cartesian. So balik class sa ano naman, sa spherical, ito yung r squared, a squared minus 2rr cosine theta minus theta prime. So, madali lang tong 1 over x minus x prime. Ayan lang siya. Siya lang yung length. Siya lang yung 1 over r. So, depende na yan kung anong gagamitin natin. Kung Cartesian, spherical, o cylindrical. Pero in this case, Cartesian tayo. Tapos, meron tayong unknown f. Class, di ba? To solve an unknown coefficient or unknown function, gagamit tayo ng boundary condition, which is a Dirichlet. So, under Dirichlet boundary condition, at the surface, ang surface natin, yan ay xy0. Diba? Plus ang surface natin, infinite plane along xy, situated at z equals 0. So yan ay f of xy0. G of s x prime equals 0. Diba? At the surface, Green's function is 0. So bali, ang gagawin natin, pasok lang natin doon. G of s x prime, yan ay equal sa 1 over square root ng x minus x prime squared plus y minus y prime squared plus, di ba z equals 0 sa surface? So yan ay 0 minus z prime squared plus f of s x prime. Yan ay equal sa 0. Di ba? Ito yung Green's function natin, g of x prime. Tapos, evaluated at the s, the surface, ito, magiging 0 to, tapos ito magiging s. The next thing, bali ang ating f of s x prime. Bali ito, negative neto. Negative 1 over square root ng x minus x prime squared plus y minus y prime squared plus z prime squared. Now class, ano na ang ating f of x prime? Kung ito ang f of s x prime, ano ang f of x prime? Sige, ako na magbibigay kung hindi nyo nasusundan. So ito ay negative 1 over square root ng ito, x minus x prime squared plus y minus y prime squared plus z prime squared. Plus yan na yung ating f of x prime. Kasi when evaluated at s, 0 to, makukuha natin to. Class, na naintindihan nyo ba? Diba? Kapag nireduce natin ito into f of s x prime, babalik tayo dito. Diba magze-0 lang yan? Magze-0 to. So bumalik tayo doon. Bali, alam na natin yung f, we can write now the Green's function. Bali, ang ating g of x prime, yan ay 1 over square root x minus x prime squared, y minus y prime squared, z minus z prime squared, minus, ano yung f? Diba ito yung f? 1 over x minus x prime squared plus y minus y prime squared plus z prime squared. Yan na yung ating Green's function of an infinite plane. So class, ito na yung ating Green's function. Now, we know the Green's function. Pwede na natin itong i-apply sa physical na system. May problem tayo. Problem. Calculate v of x if there is a point charge. Q situated at z equals t and the infinite plane along xy is grounded, meaning v equals 0. So klase na yung physics. Ito na yung physics. Calculate v of x if there is a point charge q situated at z equals d, q, and the infinite plane is grounded, v equals 0. Now class, dito na papasok yung Green's function natin. So first, dapat alam niyo yung Green's function, di ba? Second, write the charge density. Sulat ko, step 1, Green's function. Dapat alam niyo yan. Second, charge density. Class, ano ang charge density natin dito sa system natin? Q delta x delta y delta z minus d. Diba? Rho of x equals Q delta x delta y delta z minus d. Okay? Yan yung isa. Next, convert the charge density into prime coordinates. Kung yan ang rho of x, ang rho of x prime ay Q delta of x prime, delta of y prime, delta of z prime minus d. Convert. Una, Green's function. Pangalawa, charge density. Pangatlo, convert to prime coordinates. Next step, plug in. Yun lang. Ganun lang kadali class mag-solve ng potential. Okay. Ano ba ang v of x natin? Diba yan? I-write natin ha. Bale, ang v of x natin, 1 over 4 pi epsilon naught volume integral ng rho of x prime. Kaya natin shift into prime coordinates kasi kailangan natin yan. G of x prime d cube x prime minus 1 over 4 pi surface integral ng v of x prime partial g partial n prime dA prime. Now, lalong dadali yung problem natin kasi first, di ba, ipa-plug in lang. Second, meron tayong boundary condition na at the surface, potential is 0. At the surface, potential is 0. Kung 0 to, automatic 0 tong whole term na to. So actually, yung potential natin, isang integral lang yung isosolve. Tapos, yung kagandahan ng Dirac delta, di ba, hindi mo kailangan mag-solve ng integral. Ito. So ito ay 1 over 4 pi epsilon naught. So ito ay volume integral ng ano yung rho natin? Q delta x prime delta y prime delta ng z prime minus d. Ano ang Green's function natin ng infinite plane? Ito. So bali, ang dami. 1 over square root x minus x prime squared y minus y prime squared plus z minus z prime squared. So minus 1 over square root ng x minus x prime squared y minus y prime squared plus z prime squared. Yan yung ating Green's function. Tapos d cube x prime dx prime dy prime dz prime. So class, anong value neto? Yung q ilabas ko na. Lagay ko na dyan sa labas. Lahat ng x prime, di ba may Dirac delta of x prime minus 0, Dirac delta of y prime minus 0, Dirac delta of z prime minus d. Lahat ng x prime magiging 0, lahat ng y prime magiging 0, lahat ng z prime magiging d. Yun na yung value ng ating integral. Bali, ang potential natin, p of x, yan ay equal sa q over 4 pi epsilon naught 1 over square root ng x squared plus y squared plus z minus d squared minus 1 over square root ng x squared plus y squared plus z plus d squared. Class, ito na yung potential natin dun sa problem. So class, tanong, familiar ba to? Familiar ba yung potential na yan? Angela May, familiar ba yung potential na yan? Wala. Si Easy. Easy Franco. Familiar ba yung potential na yan?
Familiar po, sir.
So, san yan?
Di ko po rin sure, pero familiar lang.
Di ba ito yung sa method of images? Balikan natin ha. Balikan ulit natin. Yung method of images natin, dun sa problem na to, yan yung potential. Di ba? Ito rin yun. Yan yung nakuha natin using Green's functions. So class, nakikita nyo na yung power ng Green's function. Di ba dito sa method of images, kailangan grounded or kailangan alam natin yung value nung nung potential to boundary sa set natin sa 0. Tapos kailangan simple lang yung system natin. 'Di ba? Isang point charge lang 'yan. What if yan, line charge o kaya weird charge distribution? Hindi na natin masosolve yan using method of images. Pero kapag Green's function ang ginamit natin, alam mo ang raw. Alam mo ang Green's function. Any boundary condition, pwede mong ilagay dyan. Kayang-kaya mong isolve yung potential. So, class, yun yung kagandahan ng Green's function method. Kahit mahirap yung configuration, kaya siyang isolve. Na-appreciate nyo na ba, class? Hindi pa. So, kung hindi nyo na-appreciate, isa pang example. Last example for today. This time yung naman, spherical symmetry. Time na pala. Isang example na lang. Balik class, ibibigay ko na lang yung Green's function para hindi na tayo matagalan. So the Green's function, di ba yun yung first step? Find the Green's function, charge density, convert, plug in. The Green's function for the sphere of radius r. Class, again, ang Green's function sa mga geometry yan sa mga shape. Radius r under the Dirichlet boundary condition is given by g of x prime. And g of r, theta phi, r prime, theta prime, phi prime. Diba? Spherical tayo. So ito ay 1 over square root ng r squared plus r prime squared minus 2r prime cos theta minus theta prime. Ito yung 1 over x minus x prime sa spherical. Now, yung f of x prime natin, yan ay r prime squared, r squared over r squared plus r squared minus 2r prime cos theta minus theta prime. Yan ang ating Green's function ng bilog. Okay, so kapag alam na natin ang Green's function, pwede na tayong mag-solve ng physics problems. Now, problem. Consider a charge Q at x equals a00. So, outside a grounding spherical shell of radius r. So, yung parang sa previous problems natin, diba, ayan yung A, ayan yung R, charge Q. Tapos, grounded ito. Grounded sphere. So, ang tanong ay find the potential outside the sphere. So, paano natin gagawin yan? First ay Green's function. Meron na tayo. Second step, find the charge density. Class, ang charge density ng point charge sa spherical coordinates ay ito. Saan na ba yan? Ayan. So, for point charge, yan na yung kukunin natin. So, yan ay Q over R squared sine theta, Dirac delta of R minus A, Dirac delta of theta, Dirac delta of phi. Yan yung ating rho of x. Third step, convert. Rho of x prime, yan ay equal sa Q over R prime squared sine theta prime, Dirac delta of R prime minus A, Dirac delta of theta prime, Dirac delta of phi prime. Last step is plug in. So ang ating v of x, rewrite ko lang, 1 over 4 pi epsilon naught, volume integral rho of x prime, g of x prime, d cube x prime, minus 1 over 4 pi surface integral v of x prime, partial g of x prime, partial n dA prime. Yan yung ating potential, di ba? Tapos class, maganda kasi grounded, meaning potential is 0 at the boundary. Potential is 0 at the boundary. So 0 na yan, automatic. Now, ang ating rho of x, so bali plug in na lang natin, di ba? 1 over 4 pi epsilon naught, volume integral ng rho of x prime, yan ay q over r prime squared sine theta prime, Dirac delta r prime minus a, Dirac delta of theta, Dirac delta of phi, times the Green's function. So ito ay 1 over, haba naman nito, square root of r squared plus r prime squared minus 2r r prime cos theta minus theta prime. Tapos may minus pa. 1 over square root ng r prime squared over r squared plus r squared minus 2r r prime cos theta minus theta prime. Tapos d cube x r prime squared sine theta prime dr prime d theta prime d phi prime. Okay na to, rho g d cube x. Now, magka-cancel to. Yung 1 over r prime squared sine theta prime, tsaka ito. Then lahat, Dirac. Klase ito yung kagandahan ng Dirac delta, di ba? Hindi ka na nagsosolve ng integral. Pa-plug in mo na lang. Lahat ng r prime magiging a. Lahat ng r prime magiging a. Lahat ng theta magiging 0. Ay, theta prime pala to. Theta prime, phi prime, sorry. Lahat ng theta prime magiging 0. Ayan. Lahat ng phi prime magiging 0. Bale, ang integral natin, or the potential, yan ay q over 4 pi epsilon naught 1 over square root ng r squared plus a squared minus 2ra cos theta minus 1 over itong last term. Yung r prime magiging a, di ba? So magiging a squared r squared yan. A squared r squared over r squared plus r squared minus 2ra cos theta. So ito na yung potential natin dun sa problem. O class, familiar ba to? Yung result na yan. Sige, tatanungin ko kayo. Si Erin Beatrice, familiar ba yan? Wala. Si Flint said, familiar ba to? Wala din. Vidal. Familiar ba yung potential na yan?
Sir, same po ba siya doon sa methods of images din po? Pero sa spherical, ano po siya?
So yes, correct. Ito yung result natin dito sa method of images nung sphere, di ba? Ito. Saan ba yan? Yan yung potential din natin at this particular example. So ibang method lang using Green's functions. Now class, ang gusto kong ma-appreciate nyo is itong Green's function. Yung method of images, di ba, madali siyang gawin, kaya siyang gawin. Pero limited lang yung kaya nating isolve doon because yung boundary conditions, they greatly affect kung paano natin ipa-place yung charge, yung image charge. Now kung komplikado na yon, mahirap na siyang gawin. Pero kapag Green's function method, sana yan? Kapag Green's function method yung ginagamit natin, sana? Ito, kahit anong boundary condition yan, kung complicated man or hindi, kahit anong charge density yan, hindi lang point charge, di ba? Kunwari, meron kang infinite plane, tapos meron kang ring charge dyan, kaya mo yung i-plug in dito. Alam mo naman na yung Green's function ng infinite plane, di ba? Sa method of images, hindi natin yan kayang gawin. Pero dito, pwede. Tapos meron kang weird na boundary condition. Let's say, ito ay hindi na constant. Let's say, v of xy na yan, di ba? Mahirap na siyang gawin. So doon na papasok yung Green's function method. And this is one way to solve Poisson equation. Di ba yung Laplace equation? Ito, no charge, no outside charges. Yung Poisson meron na. Mahirap na yan. Kaya mahalagang malaman nyo kung paano yan isolve using the Green's function method, which is ito lang. Yan lang yun, class. Dali lang yan. Ayan na yung steps, oh. Ano ba yan? Step 1, Green's function. Step 2, charge density. Step 3, convert. Step 4, plug in na lang. Ito ang pinakamahirap, yung identifying the Green's function. Pero, sige, pag sa exam, hindi ko na ipapaderive yung Green's function. Pa-provide ko na lang para hindi masyadong mahirap on your part. Okay, questions?